two physical servers. So these are the two physical servers. Physical server 1 and physical server 2. And we talked about a VM running here, and it is going from here to the next server. So within no time, the VM1 should come on this physical server 2. So we can represent it like this. It is going here. And we wanted that there should be no downtime. Okay, so and I also gave you a solution that one better solution can be to have a storage server in between, which has the virtual machine disk with them. And on that storage server, the disk is there, and you just need to pass the reference that this is the disk. And reference is mostly in the form of URL or a network address. Network address, which means the IP address of the storage server, colon where the resource is available, which may be vm1.vmdk, the name of the disk, right? Here, one important thing to understand is the difference between downtime and migration time. Can anybody tell me what is the difference between migration time and downtime? Or they are the same? Anybody can try. Difference between a migration time of virtual machine and the downtime of the service running inside the web server.
Sir, I think downtime is the amount of time for which the service is unavailable to the users. And migration time is the actual time it takes to migrate the server.
Okay. So that is fine. So which one is larger? Or they are not related?
I think downtime should be greater than migration time.
Downtime should be greater than migration time. Okay. Anybody else? Suppose downtime is the VM went down for, let us say, 10 seconds because of migration. And migration actually took 20 seconds. So migration time in this example is greater. Is it possible? Now the question is, what do we consider as migration? VM1 is running here. VM1 starts running here and using resources, start serving requests. The difference between these two times is migration time. When you start migration, when the migration gets completed. Remember, when the migration gets started and when the migration gets completed, the downtime will be between these two times of T1 and T2. Suppose I call it T1 and I call it T2, then T2 minus T1 is migration time, and downtime will be within these limits of T1 and T2, right? Outside that, if there is any downtime, that will not be caused by migration. That may be due to some attack or some other issues, but not this. So mostly downtime is smaller than the migration time. Yes, do you get it? Or there is any concern? Yes, Kirtan.
Yes, sir. Yes, sir.
Okay. Now let me move to the paper and see what things they said about this. Let us read these highlighted lines quickly. We demonstrate the migration of entire operating system instances on a commodity cluster, recording service downtimes as low as 60 milliseconds. As low as 60 milliseconds. This is downtime. In this paper, we consider the design options for migrating operating systems, running services with liveness constraints, focusing on data center and cluster environments. We introduce and analyze the concept of writable working set. This is one very important data structure which they have created, known as WWS, writable working set. And present the design, implementation, and evaluation of high performance OS migration built on top of the Gen virtual machine monitor. So they created it on top of Gen virtual machine monitor, right? Because this is a collaboration between two teams, Gen teams and the TU Denmark team, which they created, right? Now, before moving forward, let me talk a bit on this diagram. And we ourselves decide that what are the things which are required for live migration. Think freely. I told you that disk is stored on the common server and they can just pass the network address and disk will be there. Now, what additional things you require to migrate? Let me give you an example. This VM1 is running an operating system. This VM has 2 CPUs, 20 GB of disk, and 2 GB of RAM, and 1 NIC card having an IP address. This you need to migrate. Yes. Now 20 GB disk does not require to be migrated because it is already there on the common storage. Yes. Now what do you need to migrate? Do we need to migrate CPUs? Do we need to migrate RAM, NIC card? I see that there is very minimal participation. Are you very busy in many activities? This is what is happening. Shell Patel. Are you
Yes,
with me,
sir.
Shell?
Yes, sir.
Okay. So let us start with you. This disk is commonly shared. Now, what additional things I need to migrate from physical server 1 to physical server 2 so that the VM1 starts running on physical server 2? CPUs, do I need to migrate? No, they are
No,
available.
they
Okay.
are available, yes.
Disk is also no.
No,
RAM?
sir. No.
RAM, no. But contents of the RAM?
Yes.
Contents of the RAM is yes. Okay. IP address? NIC card you need not need to migrate, but IP address?
Yes. Sir,
IP,
but shouldn't it be unique for both of them?
it will be only one. The same IP address should be assigned to that VM1, right? Otherwise, how will requests come?
Okay.
Right?
Yes.
So this is yes, and this is also yes. Okay. Let us talk one by one. Contents of the RAM, how much we need to migrate? 2 GB. Yes, because there is 2 GB RAM. But is 2 GB sufficient?
For RAM, no.
The 2 GB for RAM is not sufficient. That is okay. But the total amount of data transfer for transferring the RAM, will it be only 2 GB?
It can be
No.
more than that.
Why?
Because
Uh,
sir, RAM,
Yes. Please.
yeah, so because RAM actually works in pages, like it's not necessary that RAM, like in the 2 GB there would be some active pages, but there will be many other pages which are not currently in use, but are
Mhm.
there will be used. So we need to migrate them also.
Okay. But do you also want to say that there are pages which are continuously modified? Because the VM is running right now,
Yes,
and its web server is running, processes are running, pages are dirty, it's sent back to swap, coming back, and even
yes,
modified, changed. So 2 GB
yes,
may not be sufficient. I would not say it is always the case. So we need to take care about additional pages which are changing. RAM contents at the moment, plus pages changing over the time. Suppose I sent 2 GB snapshot of the RAM. I took the complete picture byte to byte and sent them over the network to physical server 2. Now I would look forward in the current RAM at physical server 1, whatever RAM I have assigned to VM1, I will see that out of that 2 GB, how many pages are changed. Suppose those pages which are changed after, let us say, 1 second, the total content which changed is around, let us say, 60 MB. After another 1 second, it is 123 MB. After 1 second, let us say there is no change, or maybe very small change like 4 KB, only single page was changed. This is how this is happening. After 1 second, again 100 MB. What should we do? Because the VM is continuously running. And it might so happen that the VM is running a service which is very busy and continuously serving requests. So the amount of pages which are changed, which are also huge, let us say 1 GB, half of the RAM is changed. What do we need to do in this case? Do we need to send this data? भेजना पड़ेगा ना ये data?
yes, sir.
yes, sir.
Okay. So when you send it, when will you decide that now I need to stop?
Once we have once we have all the recent pages there to restart the same server service or same virtual machine over another physical server, then we can stop the copying basically.
No, but see, after every 1 second, this is what is happening. When should I decide? After the first second, second second, third second, fourth second, when should I decide? Because it will go on. Because the VM is continuously running and this is online, right? So it will continuously make the pages dirty.
I guess until everything else is ready, basically if we have everything else ready, then we can switch the basically we can switch the VM once we have everything else ready. So until then we will have to we'll have to copy whatever changes are happening on the RAM of the first VM.
And what is that everything else? I'm really interested in, because you are going into the right direction. What do you want to make ready on the next machine?
All the processes that are going to change the pages, basically all the processes that are running. We have the disk, basically like the disk is shared, so that won't need to be migrated, but like the processes and instruction set most probably.
processes and instruction set. We
Not
are
the
moving
set, but the stack, I guess.
we are moving a virtual machine, right?
Like
So
basically, if
the
there would be like in the virtual machine, there would the processes that are running on, which are which are affecting the pages and the RAM. If we have all those, if we have the exact snapshot of those processes on our new VM or on our new physical server, then those processes can now start. Basically, now those processes can update the pages on its own. So now we won't have to copy them and we can discontinue doing that.
Okay. See, when we create a virtual machine, we do, let us forget about the migration for a moment. When we create a virtual machine, what do? We simply create a container, right? Which is actually a data
Yes.
structure in the main memory, right? Creating a data
Yes.
structure in the main memory, right? Similarly, when we create a process, there is a data structure, right? In the case of VMs, it is known as VMCS. In the case of processes, it is known as task, right? Okay, so that data structure is created. The data structure is given disk. The data structure is given RAM. The data structure is given, everything which we give to an operating system to run, which may be a process tree, the kind of processes you will run, you are running, how do you maintain them, right? So there is some kind of live data is required, and that live data is a very important folder on our machine known as /proc. I already told you earlier, right? This is a live file system, not available on the disk. So I require this information so that my VM, when it goes to the next machine, the operating system running on top of it should keep on working, right? So we transfer the disk, we transfer the reference, but you need to understand that the pages are dirty, it is saved to the disk. That is also happening. So that also need to be decided. When should I stop doing it? When should I keep on doing it from the next machine? So थोड़ा सा ध्यान से समझते हैं. After each 1 second, there are pages which are getting dirty. So you rightly said, sir, I should be very much prepared on the next machine that most of the facilities are already ready. So creating a container, preparing a RAM which you want to give, connection with the disk. In the RAM, a similar structure or space should be created so that pages can be directly equipped with. And then you have transferred the 2 GB content before migration, right? Remember, when I say migrate, it doesn't mean that I have migrated the VM1. I just do preparation. And that preparation involves passing the pointer, passing the 2 GB the RAM disk, then continuously updating it. So I'll keep on doing it. Once I know that, now only one thing will happen after that. Only the pages are being changed and they are getting transferred to the disk, because they may be saved, user may be saving them. Now this process has to be stopped. Now what we need to do? Once we know that everything is ready from the perspective of second machine's container, then we will only do one thing. We will transfer the changes to the disk from the next machine now. Now we will not transfer any pages from physical server 1. This decision when we take, then the actual migration happens. Then the control is transferred to VM1 on physical server 2, and it starts running from the next instruction. How do you know what is the next instruction? Because you are saving the state from physical server 1 or VM1. This is the actual process. So that instance when you decide that now I need to move on the next machine is the actual distance, which actual decision which help us in taking the final decision. It doesn't mean that it has to be taken in 1 second, 2 seconds. It may take more amount of time if the disk is changing the pages continuously, right? So this whole thing is known as pre-copy. Pre-copy, that before you doing the final commit, keep on pre-copying. But all these things, after 1 second, you are generating multiple pages. They are known as deltas. Right? We create a sign of delta by a trigonal. These are deltas, which you are continuously changing. One more thing with Jacob's paper said writable working set, which they use to minimize the time and doing this thing efficiently. See, we know working set model of main memory. I don't know whether anybody remembers this in the operating system, working set model, working set window. In file systems, we studied this. So what is that? Working set model is, let us say, we talk about a main memory. A process is asking pages, right? A process has, let us say, 10 frames in the main memory. It means it can house 10 pages. Suppose 10 pages it has already acquired from the disk. Now it requires more pages. It means that some pages has to go outside, right? Swapping should happen. Otherwise, it will not be able to house more pages because the maximum limit on number of pages is only 10. Now the question is, what set of 10 pages should be brought up so that the number of swap in, swap out are minimal, which are known as page fault, right? Do I make some sense? Page fault, yaad hai na?
Yes, sir.
Okay. So
Yes, sir.
what set of pages should I keep depends upon if I know what was the pattern of asking the pages or which pages were asked more. So suppose I can decide that these are the 10 pages which are asked frequently as well as recently. Frequently as well as recently. Then I will keep them in my working set. If some page is not asked much and a new page is asked again and again, I will involve this in working set. So working set is what? A kind of cache for me, which are the most frequently used pages. This is also related to a concept known as locality of reference. I hope you have heard this in the operating system. Yes? Locality of reference.
Yes,
So what was it? Just a minimal idea would also help. See, I should tell you that locality of reference is the pages which you are asking. There are certain pages which you will ask. They will be at certain locations in the main memory. Yes. And those pages will be nearby if there is a contiguous allocation. Even if there is an indexed allocation, they will also be nearby because the empty spaces may house multiple pages. That is known as locality of reference. आसपास की जगहों से ही page हम लेंगे. That also gives an advantage in minimum memory, reading and writing time because they are nearby to each other. Okay, so let us go to the steps of migration quickly. I just gave you the brief how it is happening. Migrating an entire OS and all of its applications as one unit allows us to avoid many of the difficulties faced by process level migration approaches. See, processes can also be migrated, I should tell you. These are the classical things. Secondly, migrating at the level of an entire virtual machine means that in-memory state can be transferred in a consistent, efficient fashion in memory state, right? Thirdly, live migration of virtual machines allows a separation of concerns between the users and the operator of a data center or cluster. See, your virtual machine may be running on any physical server. How does it matter whether it is running on physical server 1 or 2? So this gives a flexibility to cloud service provider to transparently run virtual machines on any physical servers as they want, to use maximum return on investment, right? They are there to run their business, right? So if there are 100 servers and the overall load is only equal to 50 physical servers, they may switch off other 50 physical servers. How would they do it? They will migrate all the virtual machines on only 50 servers, right? This compaction can also be done. So, and also one very important thing is if you are not feeling comfortable on one physical server or the number of resources you require are not available, then also you can get migrated, right? We have implemented high performance migration support for Gen, a freely available open source PMM for commodity hardware. Firstly, as we are targeting the migration of active OSs hosting live services, it is critically important to minimize the downtime during which services are entirely unavailable. Right? Secondly, we must consider the total migration time during which state on both machines is synchronized and in which hence may affect reliability. So total migration time, I also gave this idea that how migration time and downtime are related. So, and the overall idea is to minimize the downtime, right? And minimization of downtime will result into high availability. When you go for cloud services that talk about HA, capital HA. Okay, what is capital HA? High availability. They even talk about 99% availability, 99.99% availability. There are some benchmarks which even say 99.99999, 5 times after the decimal. This much availability that your service will always remain available for 99.59. This is known as 7 nines, availability. This is very hard to achieve, very costly because you require a lot of backups, backup of everything, backup of server, network, storage, power, everything should be backed up multiple times. Otherwise, how will you provide this much availability? So migration may help it here. If a server is not working fine, you can migrate the VM. But remember, the server should be running, otherwise migration will not be possible. Our implementation addresses all of these concerns, allowing, for example, an OS running the spec web benchmark to migrate across 2 physical hosts with only 210 milliseconds. Yesterday, I told you about spec benchmarks, spec web benchmarks when we were comparing hypervisors. Now they are able to migrate across 2 physical hosts with only 210 millisecond unavailability. What is 210 milliseconds? Downtime. Unavailability is downtime. Or an OS running a Quake 3 server to migrate with just 60 milliseconds downtime. So this is a very great achievement that such servers are migrated with such minimal downtime. I already told you about pre-copy approach. Let us read this. And I also suggest you to read with me. In that case, you will be with me on the further discussion. We achieve this by using a pre-copy approach in which pages of memory are iteratively copied from the source machine to destination host, all without ever stopping the execution of the virtual machine being migrated. Let us do one thing. Rushabh, can you hear me? Rushabh Shah.
Yes, sir.
Okay, Rushabh, can you read this paragraph for me?
We achieve no.
Yes.
We achieve this by using a pre-copy approach in which pages of memory are iteratively copied from the source machine to the destination host, all without ever stopping the execution of virtual machine being migrated. Page level protection hardware is used to ensure a consistent snapshot is transferred, and a rate adaptive algorithm is used to control the line of impact of migration traffic on running services. The final phase pauses the virtual machine copies and any remaining pages to the destination and resumes execution there. We eschew a pull approach which faults in missing pages across the network, since this adds a residual dependency of arbitrary long duration as well as providing in general rather poor performance.
Okay, thank you. See, they are talking about pre-copy approach, that before migrating, let us prepare everything ready. Another approach is pull approach, which continuously sends the pages which you require and then keep on copying the main memory like that, the way we prepare a main memory of the operating system. That takes a lot of time, right? So that is a pull approach, but this is a kind of pre-copy approach which we are using here. Okay. We already know that VMware also has similar technology, not as vMotion, right? So they could not compare with them because there were some issues, right? Technical comparisons they could not do. Okay. Let me directly come to what this paper is doing. This paper is written in very simple English, right? Unlike many papers, technical papers, which requires a lot of things to understand. Moving the contents of a VM's memory from one physical host to another can be approached in any number of ways. However, when a VM is running a live service, it is important that this transfer occurs in a manner that balances the requirements of minimizing both downtime and total migration times. These two terms are the focus here. Okay. So what are the 3 steps? First step is push phase. Would anybody like to read this for me? Anybody?
Can I?
Yeah.
The source virtual machine continues running while certain pages are pushed across the network to the new destination. To ensure consistency, pages modified during this process must be resent.
Go ahead.
Stop and copy phase. The source virtual machine is stopped. Pages are copied across the destination to the destination virtual machine. Then the new virtual machine is started. Pull phase. The new virtual machine executes, and if it accesses a page that has not yet been copied, this page is faulted and pulled across the network from the source virtual machine.
Yes. So these are the traditional, 3 things: push phase, stop and copy phase, and pull phase, which we are doing, right? So the work which this paper is doing is summarized in this diagram. Let us look at this very carefully, and you would enjoy this design, because this design only helped us in achieving the minimal time. So VM running normally on host A. This is the first stage, stage 0. It is known as pre-migration. Migration ke pehle. Active VM on host A. Alternate physical host may be pre-selected for migration. What we are doing? Let us identify the candidate server where we need to migrate. Traditionally, on the command line, you can say this physical server you should go, but you may want to identify this automatically as well. But you can give the name of the server or the IP address of the server where this should be migrated. So you need to identify that. Block devices mirrored and free resources maintained. What are block devices? What are block devices? What do we call as block device? Which device on our machine reads in the form of a block? The information is read by them in the form of a block. On your computer, which one is a block device? Keyboard, mouse, RAM, hard disk. Which one is a block device?
Hard disk.
Hard disk is a block device. Printer is a block device. So block device in this case is hard disk, that is mirrored. How do we mirror? How do we mirror? I told you in the diagram, we are just passing the reference, that is mirroring. In certain cases, suppose you say that, sir, I have 2 laptops and I want to perform this migration and I don't have the common server. What should I do? In that case, you can make, you can transfer the whole disk, or you can make another virtual machine on that physical server to become a storage server. Right? Even 2 servers you can migrate. Two laptops you can perform the migration. There is no problem. Stage 1 is reservation. initialize a container on the target host. What is a container? We heard about Docker containers, Kubernetes, right? Yes, they are containers, but virtual machine is also a type of container. Container is restrictive resource provisioning. So we will create a container, like we will create a VM there on the target host by reserving the resources. What resources you require? RAM. The most important resource is RAM. And creating an interface, network interface by assigning an IP. These two things we need to primarily, to be done. What is the overhead due to copying? In stage 2, we will do pre-copy, and this pre-copy is of what type? Iterative, again and again, again and again, आगे से आगे, पिछला जितना किया उसके आगे का copy करेंगे. This will enable shadow paging. What is shadow paging? Pages are there and they are also created on the next machine. So there are copies of those pages. Now those pages may again be modified. Then we will again change them. We will keep on changing them. I hope you all know two important commands on our Linux machine which are used for patching. Patch and diff. किसी को पता है दोनों commands? Let me write on the chat. Diff, compare, and patch. Have you seen these three commands on Linux terminal? See, all the big software companies, when they create their software and launch their updates in the form of patches, those patches are generally in the form of differences between the last binary and the new binary. Now, how do you identify those differences? So again, I'm writing on the chat. Diff a.c, b.c. When you type this command, it will show you the differences between a.c and b.c, two files. A.c is the earlier file which you have supplied to customers. B.c is the edited file, changed file. Now you are identifying the differences. Differences have come. You can record them into c.c. So I have redirected. Now to user, you supply c.c and ask him to apply it on a.c, which it already has. How does it apply? It will say patch a.c, c.c. And this command will make a.c of customer or its contents equivalent to new a.c at the provider's end. So इस तरह से content same हो जाएंगे. Similarly, this is for file. Here what we are doing in the case of live migration, what we are doing, we are copying pages and again sending the changes. So copy dirty pages in successive rounds, right? The stage 3 is stop and copy. Stage 3 is stop and copy. Now we need to take a decision when we need to stop and finally decide. So before doing that commitment, we have this stage 3 known as stop and copy. Suspend virtual machine on host A. Generate ARP to redirect traffic to host B. Do you know what is ARP? Address Resolution Protocol. नाम सुना है किसी ने? Has anybody heard about ARP? Yes, please go ahead.
I think no one knows.
Okay. So ARP is a very common, network level protocol, though it is on the boundary of network layer and MAC layer. So whenever somebody is sending anything to your machine, they will bring IP, right? Source IP, destination IP, IP protocol. But when they come to the network, the last local area network, then they need to ask who owns this IP, has this IP, because the final communication will happen at MAC layer using MAC addresses. So suppose right now I'm talking to you over Zoom, continuously packets are transmitted. But before the actual transmission happened, initially, Zoom sent certain packets to my IP and asked whether they have reached to me or not. So in the local network, there is a switch and my laptop is connected to that. Through that switch, this question is asked, who has this IP? So my machine replies, hey, I have this IP and this is my MAC address. Please send me the frame. This actually happens. So you can run this using TCP dump. TCP dump chalake, you can see all the broadcast packets, and this packet is very common, ARP. Now remember why this discussion is important, because the VM1 will be going from here to there. IP address will remain same, right? But the physical server's location has changed, and so the MAC address may also be changed. It doesn't change, that is okay. So we need to decide that every traffic which is coming now onwards will go there. Suppose you are changing the IP also, that also needs to be done. At certain places, people think that I will change the IP of the VM1, that can also be done. So this ARP reconfiguration is needed. This is a small step which needs to be performed. So generate ARP to redirect traffic to host B, suspend VM on host A, synchronize all remaining VM state to host B. These are delta copying, small changes if there are any. Finally, commitment. Finally, we do commitment in the stage 4, where we are saying VM state on host A is released. Now host A does not anymore have any information about host A. And finally, in stage 5, activation is done. What is activation? VM starts on host B, connects to local devices, and resumes normal operation. This is the overall timeline of migration. The same stages are written here in detail. Right? So what are the stages? Let me repeat: pre-migration, reservation, iterative pre-copy, stop and copy, commitment, and activation. These are the final stages. A brief about writable working set. I already gave you an idea about what is this. Working set model of main memory is quite related here, through which only we are transferring these pages. These are certain results which they have given by comparing their migration with already available migrations. There are certain additional points like managed migration, self-migration. Managed migration is a process in which two processes, which are known as daemons, they help you in managing the whole migration process. In self-migration, the VM itself manages everything, right? So mostly the implementation here is managed migration that is required, because remember that the content of the main memory are getting transferred, and these servers may be running very important services. There might be actually security issues. People can read the data in between. Yes or no? When you're migrating the main memory content, so that also needs to be taken care of. There are many papers on this where they do encryption or similar things. Right? Now, the next thing is related to comparison of various live migration techniques. So I'll give a brief about that work, and we'll also start a new topic today. Principles and performance characteristics of algorithms for live migration, right? SAP and Umea University, you might have heard about SAP, right? SAP is very popular for ERP based software and all the enterprise software. They did this. Their whole work is dependent upon what paper we have studied, Clark, right? But they did a thorough comparison. That is why I took this paper, that how the migration should be evaluated, right? So some important points. Properties of live migration. First thing is continuous service. Second one is low resource users, robustness, predictability, and transparency. Continuous service should not be stopped. Without any downtime, it should happen. Low resource uses. Does migration require a lot of resource uses? What do you think? Is migration a good idea? Should we do more and more migrations? Or should we avoid migrations?
We actually should have.
We should avoid. Why do you think so?
Yeah, hello. Sorry, we should avoid migrations.
Why?
Basically, let's say we are like while migrating, one is the downtime problem. Also, there is the resource consuming problem. Basically, in the time while we are migrating, there would be parallelly two similar system running. Basically, it will consume twice the resource it should consume.
Twice. Okay.
It can go more than twice if we are physically migrating or physically copying some stuff. Then we might need a buffer also. So these stuff actually adds up a lot, like takes a lot of resources. So which is
Okay.
not a
You
good
rightly
thing.
said. I told you earlier that a physical server can host up to 500 virtual machines, right? 480.
Yes.
Jen started talking about 100. So it is not about twice. Actually, they may be doing a lot of data transfer, and in between your migration came, and migration is an overhead, right? The bandwidth
Yes.
which is used for migration is of no use actually for the business, right? But that is good for health of the servers, health of the service, or health of one of the service, right? That is why we are doing it, right?
Yes.
Otherwise, it could be avoided, right? Second thing is frequent migrations makes a clear point that your provisioning is not proper, right? You don't have servers required for the services you run. That is why frequent migration is happening, right? Or the initial resource allocation is not good because your VM is migrating. Why? The required resources are not here. In worst case, this might also happen that you are actually doing swap. This physical server to VM1 is going, and you might also do this, that VM2 is going from this server to this server. Can we do this? VM1 from here to there and VM2 from there to here. क्या ऐसा करना पड़ सकता है? See, this is also possible that the required facilities or services are available for VM1 on physical server 2. It is a small VM, and the remaining space can be allocated to VM2 because the available space on physical server 1 is not sufficient for VM2. Unless otherwise somebody goes from here, it is not possible. This is known as migration swap. It might also be possible. There might be more than one server involved. From one server, a VM is going to another server. From another server, a VM going to another server. And from that another server, the VM is going to first server. This may be a continuous cycle which is happening, and migrations are to be avoided. I hope this makes sense. Robustness.
Yes, sir.
The hypervisor, the VM, or any hosted application should not risk crashing or freezing due to the migration process. Can migration fail? Yes, it can fail. In that case, your migration daemons or migration processes should be equipped for this failure, and they should be able to handle the situation by running the VM for the instance on the physical server 1 only. Right. Second issue which comes up about security, which is not listed here, the contents may be changed. Remember, the main memory contents are going. All the decrypted data is there in the main memory. All the keys are there in the main memory, and they are going over the network. right? And these servers are what servers? They are the web services running on the cloud. Predictability, the prediction of the migration time, downtime should be able to do, right? See, prediction can be done because you have sizes available and you know the past behavior of page dirty rate. That way you can decide what will be the time required. Transparency. Migration का पता किसी को न चलना चाहिए. Suppose I am a VM owner at Amazon AWS. I am only aware about my VM, its login credentials, IP address. Other things I am not aware that on which physical server, which rack, which kind of server it is running. Do I need this information? Do I need this information that on which physical server I am running as a server owner?
No.
No, this information is not required unless otherwise you have dedicated servers for hosting and you manage everything, right? This is known as transparency in the distributed systems. This is a very important idea. This should be provided in all the solutions of such kind. So live migration challenges, what are the challenges? Transfer rate problem. Can we create a dedicated channel? No, it will be a shared channel. Everybody is transparent. The page resend problem, pages are dirtied again and again and we need to send. And the missing page problem. Some pages may be missed or corrupted. So you need to again send them. So both the processes, so that is why I said managed migration is very good in that sense. So what are the copying mechanism they are using and how they are comparing? Different page routing page rate they have introduced, the 10 MB per second, 100 MB per second, 1 GB per second. And then they are, what algorithms they are evaluating? Post copy, hybrid and pre-copy. And the benchmark name is app-mem bench. Post copy, hybrid and pre-copy. The benchmark name is app-mem bench. Test bed has changed. Servers on which they are running has changed. You can see from here. In one they are using gigabit Ethernet, in one they are using iVark, a very high-speed network. Third, they are using SAP HANA benchmark. Again, the same algorithms they are comparing with second benchmark. Right. So I told you the law of experimentation. This should be very well defined where you are doing. Anybody should be able to reproduce. So as the page dirtying rate goes on, the algorithms which we are comparing, they also show different results, the time. So pre-copy and hybrid, algorithms are shown. Hybrid is a pre-copy plus post-copy approach, right? That they, according to them, is better in certain cases, right? So this is a good paper to do a project on comparison of live machine migrations, right? Just a brief we wanted from this. Okay, now this is the time we should start talking about something else. Do you have any questions, any kind of comment, any kind of discussion you require on whatever we have studied so far? Anybody?
No, sir, clear.
Okay. Now I'm going to talk about virtual machine placement, VM placement. What is VM placement? As the name suggests, how to place virtual machines on physical servers. Now you may say, sir, हम तो virtual machine बनाते हैं, उसको शुरू कर देते हैं, and then it starts working. What is this placement all about? Remember, you are working with a single physical server where you are creating VMs, running them. In reality, what will happen is your cloud will comprise of many physical servers. Just a minute. One physical server, two physical servers, 3, 4, 5, 6, 7, 8, and they are connected through a very high speed network. I can call it as a network through which they are connected. So everybody is connected through this network. Not necessarily in a star topology, just I'm giving an example of a data center where so many servers are there. This network connects all these servers, and these servers have multiple NIC cards. They are capable of running many virtual machines on them, right? Because the resources available on these servers are of this kind. Let me give you an example. They may have at most 2 processors usually. Each processor having, let us say, minimum 12 cores, RAM of around 128 GB. This is the kind of resources we have on such servers. Now, what do we do with these many resources? We need to occupy these resources, right? Then only we will be able to say that this cloud has good resource utilization or higher resource utilization. And then the term comes up in the picture, ROI, return on investment. So somebody who is investing to build such a cloud, they would want that their servers are completely occupied, running a lot of load, so that pay-as-you-go accounting of cloud can result into good revenue. Yes. So VM placement is what? You need to maintain a queue of the request you want to run. Request 1, 2, 3, 4. These requests are coming up. And then you are placing them on any of the physical servers. How many physical servers are there? So many physical servers are there. So suppose all the physical servers are empty right now, they are not running any load. And when I say VMs are coming up, these are basically jobs for people who are buying IaaS on your machine. So their requests are coming up that their VM should be started. So where would you start the first VM? There are 7, 8 servers available. Where would you start? Should I keep this first VM on this server? No problem. Where should the second VM go? Where should the second VM go? Any empty physical server or the same physical server where one is kept? Any idea? Let me make it little interesting. Have you heard about a problem known as knapsack problem?
Yes, sir.
What is that?
Basically,
have
we have a limited weight that we can carry, and we want to maximize the value. We have multiple items with certain weight and value.
Okay.
So we
So what you want to do that you have a bag and you are a thief in a
Yes.
house which has a lot of items, but your bag has a capacity, right? Capacity of, let us say, 100 kg, or there can be a volume also, but let us talk about 100 kg of that. Thief wants that items it should fill the bag should have at most value, right? So that he can maximize his, profit. Stealing is not a profit making business. I don't know. But this is what his aim is. Another problem which is quite related in theory is known as bin packing problem. Have you heard about this? Bin packing problem. So what is shown here is there are 8 bins. Bins are boxes, right? Empty boxes. And I have many items which I need to place in those bins which are free. How should I place those items? Is bin packing problem. Now in bin packing problem, there might be an optimization criteria that fit all the items in these boxes or bags, right? And every bag should have around equal quantity. This may be one example. Second objective may be no, equal is not required. Fill as minimum bag as possible. 8 bag हैं, capacity 800 होती है, total items हैं जिनकी total weight है 500. Just fill 5 bags. 3 bags should remain empty. Do we understand this? This is known as bin
Yes.
packing problem. And bin packing problem is the theoretical foundation of many scheduling resource allocation problems, right? We do resource allocation in this manner. We have multiple codes where the job should be assigned. CPU scheduling, right? Similarly, this VM placement. Now, VMs are coming up. What do VMs have weight? Do we have weight of VMs? For physical servers, we have weight. 2 processors, 12 cores, 128 GB of RAM. Do we have similar idea about a VM? Yes. Resource needs of a VMs are specified. What does it require? 2 vCPU. What additionally things you require? 20 GB of disk. What additional thing you require? 2 GB of RAM. Yes. Now this is the requirement and that is the availability. Where should you place? And we should also think that when we are placing a VM on a physical server, because this will be happening in a centralized manner, there will be a cloud manager which will be placing these VMs. Later state, they should also have additional space for future improvement. A virtual machine may say after 2 hours that I require more resources, that much space should be available. But suppose it says that it doesn't ask for many more resources after 2 hours, then you are wasting your resources. Yes. It might also happen that you have allocated VMs to a physical server, they may get migrated. All such things need to be covered up when we are talking about virtual machine place. But one thing is clear, that return on investment should be higher. So we will maximize this by filling servers and keeping certain servers for free. The second version of bin packing problem. जितने कम बैग भरें उतना अच्छा है, जितने खाली रहें वो better है. ऐसा क्यों? Why would a cloud provider want that? That some servers should remain empty and fill as many servers as possible, but the whole load should be allocated with minimal number of servers.
Basically,
Any
if
idea?
some new,
Yeah.
sorry.
Yeah,
So
go
if
ahead.
some new server, new request come in for a new VM, then we can place if we have enough availability.
Yes, that is there. But see, nobody is going to ask us that. The most primary idea is every server consumes a lot of resources when it is running. The most important resource is power and air conditioning. Right? It's running server consumes a lot of power, carbon footprint is very high. So if out of 8 only 5 servers are running and all the customers are served, they would be very happy. Their data center will be energy efficient because The whole load is they are able to run on minimal number of servers. That is the main idea. Second thing is they may require certain servers to serve in the case of emergency fault tolerance. So they can also do that. Okay. When I gave you the description of this diagram, you might realize that there is a lot of scope of innovation. Designing new VM placement algorithms, how the VM placement should happen, right? So there are so many algorithms available. Thinking about that later migration should be minimized. So there are people who have designed algorithms which says that we will think about future migration. They should be as minimum as possible. There are algorithms which says that we will take care about energy efficiency. There are algorithms which says that we will talk about future requirement. This is a web server of a popular company. They may require more resources very soon, right? All these ideas are there. But one additional idea is there, which is very important. And I hope some of you might have heard about this, is known as performance isolation or performance interference. Performance isolation and performance interference. किसी ने सुना है इसके बारे में आप में से? Okay, so let us forget about these terms. Let me give you an example. On your laptop, can you write a program in C or whichever language you love that can give 100% CPU utilization? And suppose you have 4 cores, then 400% utilization, not 1400, 400. Can it be done?
I don't think so, no.
You cannot generate 100% utilization on a computer, is it? Have you seen 100% utilization on your machine anytime? Anybody? Nobody? Isn't it? Yes,
Um,
yes.
Not in my computer, but I have seen like 100%, like the CPU utilization touching 100% on AWS cloud VM basically
Okay.
on an
Okay.
instance.
Okay.
So I don't know if that correlates or not, but
Suppose I ask you this question, can you write a program which generates 100% utilization? Don't think about multi-core, single processor machine. And can I write a program which will generate 100% CPU utilization? What do you mean by 100% utilization, right?
basically using the CPU for
Using more
100%.
or using all CPU?
Using whole CPU would be the
The whole
term.
CPU cannot be whole or half, right?
Whole as in
Yeah, CPU time, completely using CPU time, right?
yes, exactly.
So then you have simplified it. Can we write a program? I'm not asking you to write a program. Just give me an idea. Can a program which can consume 100% of CPU time be written?
I guess it can be written.
Mhm.
Like if
What
we
would
have
it
to
involve?
choose.
Mhm.
Sorry.
What will it involve? What kind of things you will run so that 100%
So
utilization?
we need to run instructions such that they do not create any holds basically,
Good.
as we have seen in the
So
CPU
any instruction you know
architecture.
which does not create a hold or stop, pause for some time, right?
Mhm.
Anybody else can also contribute, right?
I don't know such instructions, but like,
Or they are not available?
I'm sorry.
They are not available? Are you saying that there are no such instructions available?
No, I don't know if there
Okay,
exists
you don't
such
know.
instruction.
Okay,
Yeah.
anybody else? Anybody else? But we had a good discussion. You went into the right direction. There are very easy instructions which can do this. Think about it.
So I am just guessing while minimizing the usage of input-output devices. So if we
Yes,
do not use
yes.
that can help us.
So give me the example instruction. Or
I'm
example,
reading
C statement. Even C, Java, Python is all right.
something like reading and writing into register, like not register, but basically on RAM variables, which won't actually
Remember,
like,
again, you are going to again you are going into RAM, right? And that
okay,
may result
like,
into a page fault, right?
yeah. So instead of RAM, what we can use is like, okay, that is bit difficult to do, but is that possible to just use registers in
Anybody else?
CPU?
Anybody else? Anybody else? You are in the right direction, but you are not saying any instructions. Let me write this. Would it make CPU free? A, B, C are floating point variables. A is equal to B multiplied by C, and I need to run this for 10 million times. Is there any reading, writing, input, output involved? चलेगा क्या ये?
Mostly yes.
Mostly yes. This is a very, very decorative answer. Why mostly? Why not all the times?
Like, if this is the only program that is running, then there is high chance that it will work. Basically, because it won't have to refetch A, B, and C from somewhere else.
Okay.
So that won't create any pauses or halts.
Okay. So you agree that this program will generate 100% relation if there are no other programs running which can
Yes.
make its life difficult, and it may not get scheduled in between. There are IOs, right? Otherwise it will work, right?
Mostly yes, yeah.
Fair enough. Anybody else? Okay, so let us do one thing. If we run this program on a machine, and what will happen, that machine will allocate this program to one CPU, and that CPU will remain continuously busy, right? On operating systems like Windows, if you have multiple cores, then this program will get migrated from one core to another core to another core, keep on moving because of load balancing features. But every core where it will run, it will generate 100% utilization, right? So this will be doing it. You can involve more instructions here, more addition operations, multiplication, division operations you can involve, and it will generate 100% utilization. Okay. Now, what is the purpose? Why I'm doing this? Suppose I'm running this program for 10 million times. How much time does it take? Let us say the time taken by this is 1 minute. I'm just taking an hypothetical example, 1 minute. Okay. Suppose there is a single core machine and it is taking 1 minute with 100% CPU utilization. Okay. And this program name is A.C. And when I run it, it becomes A.out, right? We run C programs. A.out is the process which will run. If I run A.out 2 times, so I create 2 processes, the same program is running twice at the same time. How much time will it take? When it was running alone, it was taking 1 minute, 100% utilization of CPU. If there are two programs running together, of the same program is running twice, two instances are running, how much time will it take? Will it take 1 minute? Will it take more than 1 minute? Anybody? Do you understand what I'm saying? किसी को कोई confusion है, कुछ पूछना है तो बताएं. See, a single program was taking 1 minute when it was the occupant on the CPU for the whole time. If I run two programs, they would never be completed in 1 minute. This is true. Yes or no? Because
Yes,
a
sir.
single program was taking 1 minute, how two programs which are running the same thing can get completed in 1 minute? No, they cannot complete in 1 minute. They will take 2 minutes or more. Why more? Because of switching between these two programs they will be using. It is why they may require more than 2 minutes. Okay. If you understand this concern, think about two virtual machines running on a single physical server, running this kind of a program on a single shared CPU. They are running the same program. Will they affect each other? No, they will not affect each other, but the time will be distributed between them because the resources are shared. Single CPU is shared between two VMs. So they will be sharing that CPU, and that CPU will give vCPUs to both the VMs in the form of vCPU. But vCPU is nothing. It actually runs in the same CPU. So sharing is happening. It means they are interfering with each other. This interference,
Sir, excuse me.
yes.
So I'm so sorry to interrupt, but we are having another lecture. So can I leave?
Okay. So we'll stop here.
sorry.
Just 30 seconds I'll take. We'll continue with this problem in the next session, right? And if you get time, please programs and you yourself know that what is the utilization we are generating, right? So we will stop here. Yes, Kirtan,
Yes, sir.
right? So see you then. Thank you. Bye-bye.